Welcome everybody. This is the first course on probability, and this is a very important course, specifically if you are aspiring to get into data analysis, data analytics, data sciences, machine learning, financial engineering, and so on and so forth. So you cannot just neglect this subject. So having mentioned its importance along with the motivation for you all to study, let me start off with key terminologies. Now you will have to get these basics correct, and everything that you are going to be learning and applying on probability will be involving around these basics. Now foremost, the first term that you will have to understand is what is a random experiment. Now you would have heard people always say conduct a random experiment. Now what exactly is a random experiment? Now the definition is as follows. It is the process by which we observe something that is uncertain. So the key term is uncertain. So whenever you want to observe an event which is not really certain, then that process that we employ is called a random experiment. Example, say tossing a coin. That's the first one. Number two, you roll a die. And number three is forex trading. Now let me just take this tossing a coin. Now I got a coin, a fair coin, meaning on one end I've got a head, the other end I've got a tail. Now will you be able to tell me, if I were to toss this coin, what would I get? Of course you wouldn't be able to say. Of course you can guess, right? So that guess as a probability also. So coming back to the random experiment, the process by which we observe something that is uncertain. Next is you roll a die. You got a die. You are rolling a die. Can you tell me what would turn up? You wouldn't be able to tell me what would turn up, but you would be able to observe what turns up. So that is why we call these things as random experiment. Forex trading. Nobody knows. For example, the US dollar versus the UK pound. If you want to buy a UK dollar, you have to pay 1.70 USD to get it. Now the next minute, this 1.70 will either fall or will either rise. Nobody can tell. So it is also called a random experiment. Okay, so much so for giving you that detail. As we progress in the subject, you will have a better understanding. Next is outcome. Now I just mentioned to you the process of observation, and then I asked you, can you tell me what would you get when you toss a coin? You might say a head or a tail. Now that observation which you are getting is defined to be as the outcome. Similarly, when you roll a die, if 3 turns up, that is an outcome. So the result of performing an experiment, that result is called an outcome. So we have learned random experiment, we have learned outcome, and next we go up to what is called as a sample space. Now what is sample space? So let me write this down. What is an outcome? It is nothing but the result of a random experiment. So now I think once I finish the sample space, I will reiterate everything again by explaining to you so that reinforcement takes place. Okay, now sample space. What is sample space? Now the set of all outcomes. When you toss a coin, you get either a head or a tail. So this is a sample space. So you collect all the outcomes and you put it in a in a set, that is what is called a sample space. Now in case of a die, what will be the sample space? It can be 1, 2, 3, 4, 5, 6. So you collect all possible outcomes that might turn up and you place it in a set and you call that particular set as a sample space. Now next, the 4x. Suppose the fluctuation of the share prices, that is also can be put in a sample space. What values do you think this particular currency can take? It can take anything between 0 up to infinity, not including infinity. Now you may be wondering, oh, is it really possible? But do you know that there are certain currencies against the US dollar, they are quoted in 100,000s like that. There are certain currencies. So we may not be able to judge. We may not be able to say what goes up, what goes down, specifically in Forex, right? Because one simple news can literally skyrocket or plummet the currencies. So that is why I'm placing S is the sample size, or I would say the sample space is consisting of all numbers between 0 and infinity. Now the next important concept that you will have to know is event. Now what is an event? It is the subset of a sample space, or I will say subset of the sample space, to which we associate a probability. So let me give you this illustration so that you will have a better understanding. This is the definition. Now for example, a fair die is tossed. Okay, this is a die. Now this die is being tossed and you are asked to find the probability of an even number showing up. Do you understand the question? So what is the sample space for the die? You can have 1, you can have a 2 or a 3 or a 4 or a 5 or a 6. This is the sample space. Now they are asking us to find the probability of an even number showing up. So what are the even numbers in the sample space? You got 2, 4 and 6. Write them down. 2, 4, 6. Now this 2, 4, 6 is present in the set called event. Now we are clearly seeing that the event is contained in S. So event is a subset of a sample space. Now we are not yet finished. Now what we need to do, we need to find out the probability of the event. So a number has to be associated with the event. So what is the event? We are looking for even number showing up. So the probability of E is nothing but, before I could give the probability, let me write down what is E. An even number showing up. So we are associating a probability to this event. What is that event? An even number showing up. So how are we going to calculate that? There is a formula. What is the formula? Exhaustive case, total exhaustive cases. That means 1, 2, 3, 4, 5, 6 are there, and you have favorable case in the numerator. So exhaustive cases go in the denominator, favorable cases go in the numerator. So in other words, P of an event is nothing but favorable case divided by exhaustive case. So what are the favorable cases here? 1, 2, 3. 3 favorable cases are there. What's the exhaustive case? 6. So I can safely conclude the probability of an even number turning up is 1 over 2. So what have we done? We have associated a probability to the event. What is this event? Probability of seeing an even number when the die is tossed. And what is the number? 1/2. So that is how we understand the concept of event. Okay, the next important concept that we will have to know is the axioms of probability. Now let me take A to be an event, any event. Now the probability associated with A is always greater than or equal to 0. So what it means, in simple terms, you cannot have a negative chance of something. When I talk about something, I am talking about an event happening. So this is never going to happen. Now let me explain to you in this illustration. Say you have Sarah. Now Sarah has a bag. Now in this bag she has red balls and blue balls. Now I got a question. What is the probability? I'll write it as PROB, that Sarah picks a red ball. Now this is the question. Now I just mentioned to you that Sarah has a bag and it has got red balls and blue balls. Now she has got 3 red balls and 5 blue balls. Now given this information, you are expected to find the probability of the event of picking up a red ball occurs. So in this case, if I were to mention that event to be as A, we are looking for the probability that Sarah picks a red ball. So as I mentioned to you, the formula is exhaustive case goes in the denominator, exhaustive cases, and favorable cases numerator. So exhaustive case, the total exhaustive cases means total available ball, 3 plus 5, 8, and the favorable case 3. Now when you divide 3 by 8, what do you get? 0 times 0, 5, no, 4, no, 8 3s are 24, 6, 0, 7, 56. So approximate value is 0.37. Is it not greater than 0? This value is greater than 0. So that's exactly what we are talking here about. The probability of any event occurring will always be greater than or equal to 0. And this is the example that follows the first axiom. So having given you this, let me move on to the next page and continue. Okay, so this is axiom number 2. Let me write that down. Now what is axiom number 2? Probability of S is equal to 1. Now let me give you an understanding. Now let me take a sample space of the die. I can get a 1, a 2, a 3, a 4, or 5, or a 6. So this is a sample space for a die. Now it clearly says here that the axiom 2 is probability of S is equal to 1. So what it means? Now let me talk about a certain event. Now we need to choose a certain event to explain this. A certain event that covers all of the outcomes in a sample space or in the sample space. Now that probability is equal to 1. So that is the understanding for this P of S is equal to 1. Now if I were to take a die and ask you to roll it, and I'm associating a certain event. I want a number. To show up, and more importantly, that belongs to the set. So this is going to be my certain event, a number to show up, and more importantly, that number should belong to this set. So my question is, what is the probability of this certain event happening? Now clearly this certain event covers the entire sample space, and when you roll a die for a number to show up that belongs to this set is what? For sure it is going to be equal to 1. You are not going to be getting any other number apart from the numbers that I have mentioned here. So for a number to show up that belongs to the set is equal to 1. Now I can also give another illustration. Say for example, Daniel has a box, and in this box he has a red ball, one red ball. My question is, what is the probability of Daniel picking the red ball? Now let me just take the sample. What is the sample space here? It's just one red ball. That's all we have got. And what is the event we are talking about? What is the probability or the chance existing for Daniel to pick the red ball? Definitely when he places his hand, when he puts his hand into the box, all that he is going to get is a red ball. And that is what he is going to pick up. And that probability is always going to be equal to 1. Because this event covers up all of the events that are placed in the sample space. So that is the key here. Okay, we got axiom number 3. Now what is that? The probability of mutually exclusive events. Now let me just take those events. Let A1, A2, etc. AN be mutually exclusive events. Now what do you mean by this? It means events that cannot happen at the same time. If the sun is out, the moon cannot come out. Of course, some would argue in a different manner, but this is the phenomenon. If the sun is shining like this, the moon is not going to be seen. So sun and moon are mutually exclusive. Now if you are to find the probability of the mutually exclusive events, if you wanted to know the probability of A1, now let me just place this as AN, A1, A2, etc. AN. Okay, coming back to the point, you might be wondering, why am I placing A1 union A2? Now in probability, union means OR and intersection means AND. So have that in mind. So when I say probability of A1 union A2, union A3, etc. AN, it means either A1 or A2 or A3 or A4, etc. or AN occurring. This is equal to probability of A1 plus probability of A2 plus probability of A3 plus etc. up to probability of AN. So this is the all important formula. Now having given you this formula, we need to have an illustration, right? So without illustration it's not easy to understand. Now let me take, say, Tom. Tom has a pack of cards, and they are 52 in number. Now of these cards, Tom has got red cards which are 26 in number, and say green cards which are 26 in number. Now clearly, if red card comes, green card cannot come. If green card comes, red card cannot come. So the question is, what is the probability of Tom drawing either a red or a green card? Do you follow me? So with this, he has to draw only one card. So that is the condition. You have to draw one card. So if a green card shows up, red card cannot show up. Red card shows up, green card cannot show up. So we are expected to find the probability of red card union green card. And that is equal to probability of red card plus probability of green card. Now what is the probability of red card? I told you total exhaustive case 52, favorable case 26. So this is 26 over 52, that's 1 over 2. Similarly, probability of green card is 26 over 52, which is equal to 1 over 2. So the probability of this event RC union GC, red card union GC occurring, is 1 over 2, positive 1 over 2 is equal to 1. So definitely when he picks up the card, a card is going to come out, and that can be either a red card or a green card, and that is going to be a sure event, and that's why we're getting 1. So I hope you are able to understand this. This is the third axiom. So these are all lovely axioms, and for each of these axioms I've given a supportive illustration, and we will move on to the next one. Now the next concept that we will be learning is to find the probability of independent events. So let me just take A and B to be two independent events, and then you have B to be also an independent event. Now if you are asked to find the probability of A and B occurring, this is how we place the symbol. In probability we refer to this as AND. So I have that important inference. So if you are expecting to find the probability of A and B occurring, then the formula is probability of A multiplied with probability of B. If you were to represent this in the set theory notation, or I would say in Venn diagram notation, you got A and B. A intersection B is nothing but collection of all X such that X is present in A and X is present in B. So this is the understanding for A intersection B. So this is the Venn diagram. Now I have drawn the Venn diagram. The question comes, how are we going to utilize this in our probability? So let me give you an illustration, and that's the best way to understand this concept. So this is the question. The question is, find the probability of selecting a red card and a card with 6 on it, or you can simply say and a 6, when we draw a card randomly. So that's a question. Now the total exhaustive case, total number of cards is 52. So the probability of the event of drawing the red card is, how many red cards do we have? There are 26 red cards are there, divided by 52. So this is going to be 6 times 2, 12, 1, 4, 5. So it's 1 over 2. I'll just mention it here. There are 26 red cards. Now what is the probability of drawing a 6 and there are 4 cards with the label 6? I'll just write it like this. There are 4 cards with the label as 6. Okay, so that's going to be 4 over 52. So that would give me 1 over 13. Now the question is, find the probability of selecting a red card and a 6. So the occurring of one will not remove the occurring of the other. So the occurrence of one card will not interfere with the occurrence of the other. So that is why we are dealing with this particular formula, probability of A intersection B. So probability of A intersection B is nothing but probability of A and B occurring. So that is going to be probability of A multiplied with probability of B. Probability of A, if I were to take it as 1 over 2, that has to be multiplied with 1 over 13, which gives me 1 over 26. So this is the solution. Now why am I actually starting off with P of A intersection B? Because we need that to study conditional probability. So just to render an error of clarification, in this case I have taken P of red to be as 26 over 52. Now in a pack of cards there are 26 red cards and I have taken P of 6 is equal to 4. Now why am I taking the value to be as 4? It is imperative to understand that there are 2 reds which carry the label 6 on them and there are 2 blacks which carry the label 6 on them, and that is the reason I have taken here 4. So the understanding here is, find the probability of the card being red and it is being labeled as 6. That is the requirement, and that is why I have taken them to be as independent events and not mutually exclusive events. Because of the fact that A and B are independent events, I am able to utilize this beautiful formula. I hope that clarifies and we'll move on. Okay, so now we have come to conditional probability. Now this is represented as P of A slash B. Now what is the meaning of this? We are expected to find the probability of A occurring given that B has occurred. Now this has got a lovely formula. P of A given B, we call it like that, is equal to P of A intersection B divided by P of B, where A and B are independent. Events. Now let me give a beautiful example. We are asked to find the probability of, say, drawing a heart given that a heart has been already drawn. So the question wants us to find the probability of drawing the second heart given that already the first heart has been drawn. So we are given B. What is B? This is the first heart. Now I will just try to complete the solution here. Now what is the probability of B? In a pack of cards we got 13 hearts and that divided by 52, so that's going to be 1 over 4. Now given that the first heart is drawn, now what is the probability of the second heart? A is the second heart. Now the first heart has already gone, so we got 51 and the probability favoring A is 12. P of A given B is equal to P of A intersecting B. So that's going to be P of A multiplied with P of B divided by P of B. Don't cancel these things off. You need to place in the value. So P of A is 12 over 51. P of B is 13 over 52 divided by, I could have just placed, but it's okay, 13 over 52. 13 over 52. So when you flip this, what do you get? The 52 can be cancelled. You can cancel this 52 with this 52, cancel this 13 with this 13, and you are left with 12 over 51. So what is the solution? So therefore, the probability of drawing the second art, given that the first art has already been drawn, is 12 over 51. So this is a beautiful illustration. Now as we go on in the course, we will do many such questions. Now we will stop here for the first lesson and we will meet again in the second lesson. Thank you, students.